Welcome to a session on characteristics of lasers and applications. Laser, the full form of laser is light amplification by stimulated emission of radiation. Let us see the ordinary light versus laser light. Ordinary light is emitted by spontaneous emission, whereas laser light is emitted by stimulated emission. Ordinary light is incoherent light and laser light is coherent light. Ordinary light is having divergent property and laser light is having highly direction. Ordinary light is polychromatic and laser light is monochromatic. Ordinary light cannot be focused to a sharp beam and laser light can be focused to a very sharp spot. Let us see some of the special properties which distinguish lasers from ordinary light source are directionality, high intensity, monochromacity, and coherence. Let us see one by one. What is directionality? A very tight beam which is very strong and concentrated. The directionality of laser beam is expressed in terms of angle of divergence phi. Let us see what it is. Divergence or angular spread is given by phi equal to R2 minus R1 by D2 minus D1. Here D1 and D2 are any two distances from the laser source emitted, and R1 and R2 are the radii of beam spots at a distance D1 and D2 respectively, as shown in figure. Here R2 is the radius of the second beam, R1 is the radius of the first beam, where D1 is the distance between the first beam spot and laser source, and D2 is the distance between laser source and the second beam. Laser light has less divergence, which means that laser light has more directionality. So next, let us see the next property, high intensity. Laser light having high intensity. In case of lasers, light is a narrow beam and its energy is concentrated within a small region. The concentration of energy accounts for greater intensity of lasers. Let us discuss another characteristics, which is monochromacity. So what is monochromacity? Mono means single, chromacity means color, single colored. So if you look at the normal light, it is multiple wavelengths. If you pass this ordinary light through the a particular prism, it will be split up into 7 colors. So which means that light is combination of 7 colors. Diverged means they are not parallel, and dispersed, so it is multidirectional. Whereas if you take this laser wave, it is having monochromacity, single colored. So here you can see yellow light, red light, and green light from ordinary source of light. If you concentrate on this figure, it is a laser. So laser is emitting only red colored radiation. So it is monochromacity. Next one is coherence. So laser light highly coherent. So let us see what is coherence. So this figure represents the incoherent light waves and this figure represents the coherent light waves. Let us see what is coherence in detail. If any wave appears as pure sine wave for longer times and infinite space, then it is said to be perfectly coherent. So practically no wave is perfectly coherent, including lasers. But compared to other light sources, lasers have high degree of coherence because all the energy is concentrated within a small region. There are two independent concepts of coherence. One is temporal coherence, another one is spatial coherence. Here you can see. So this laser beam appear to be a sine wave. So In an approximation, we can say that if any wave appears as a pure sine wave for longer times and in infinite space, then it is said to be in perfectly coherent. So the light which is got emitted from the laser is coherent. Let us see applications of lasers. So we can use the lasers in communication field, medical field, and general industry, so on so. So let us see individually. Lasers are used in optical communications due to large bandwidth in communication sector. The laser beam can be used for the communication between Earth and Moon or other satellites due to the narrow angular speed used due to establish communication between submarines, underwater communication. So, with lasers, underwater communication is also possible. Let us see the applications of lasers in medical sector. For removal of cataract, use it to detect and remove stones in kidneys. Use it to detect tumors in brain. Let us see the applications of lasers in industry. So lasers are used in the purpose of welding, cutting, and drilling. So these are the some applications. So you can use. There are wide range of applications actually in printing, in displays, in R&D, in military, optical storage, instrumentation and sensors, medical and aesthetics, lithography, materials processing, and communication. So these are some broad areas of applications of lasers. Thank you for watching.